Hello. Right, assembling lithium battery packs for your own electronics projects. As someone commented in the previous video, these are for electronics, not power tools. These laptop batteries are probably not high discharge ones that you need for the power tools or things like big drones and that type of stuff. So electronics fine, a couple of amps a cell load. Basically don't use them 2.5 amps or whatever maximum discharge, and try and keep it below that. And I'll do a separate short video showing the option for power tools I use. Right, anyway, cells and batteries. That's my typical assembly. The bigger one's probably going to go in a box. You can see that's 3 series, 2 parallel arrangement with a 3-cell protection board. A protection and balance board. Both protection and balance are absolutely essential if you don't want your battery packs either just getting wrecked or catching fire and cells bursting and things like that. So this is going to be a 4x4 pack, 4 series, 4 parallel. So that is a 4-cell protection and balance board I'm going to use, which should keep it reasonably safe. Now these are not charging control, they are purely protection. The charger must still be set to the correct voltage with the current limit, and hopefully, preferably a cutout once they reach full charge, so they're not held at full charge forever. Now anyway, I'm not going to go through all the detailed prep. I've already separated all these out. I'll just show you how I separate the cells. I mean that one's actually that one had a faulty weld on it. It popped whilst I was taking it out of the case, but it doesn't matter. I've got your spares. If you're going to cut them apart like this, start on the negative end, because it's fairly tight, and if you manage to scratch through the insulating sleeve on the things, if you're on the negative end, nothing happens because the cutters are already connected to negative. If you do it on the positive end, you get sparks and possibly damage the cell. So separate the negative end first. None of the cutters I'm using this are very good, because I don't want to wreck good ones cutting these metal strips. But once you've got the negative end separated, you can then separate the cells, so you've got no risk of digging into the side of the cell and the negative contact case whilst you are separating them. So again, that's that one. Let's do a couple. Kind of nibble through that because there's not much space, it's very tight. But again, once the negative's cut, then the positive end is relatively easy. So the cutter's not good, but you can see it's near enough to pull apart. So that's that 15. I won't need one more cell, so I'll just take that one off there, and that's the set of 16. I'm not going to bother showing that. I'll show that now. Now what I use for making these up are these interlocking cell holders, or cell ends, I don't know what you call them, which are readily available online. You can also get them as moulded sets in larger sizes as one piece rather than to assemble them, but I'd rather use the individual one because it allows you to make any combinations, size and shape you want. Again, I've already slotted some of these together to make up the ends. So that's one full end, and then I can put 4 strips on the other end as I assemble it. I think that's going to be easier than trying to force all 16 on at once. So see how it goes on these. The next stage of preparation is just bend the tags in so they're within the profile that these are going to cover. Just remove that bit of wire, but you've still got a bit of the tag attached to the battery that you can use as a solder tag. That way you're not soldering directly to a cell. Soldering to cells is not a good idea. I have done it as a push, but it can damage the insulation and cause them to overheat or fail later on. So basically, once you've got the tags bent in, just stack them in the frame. And again, I'm not going to do every one, just do a couple. That's another one that's got an existing solder tag. And put them all negative down, and you just keep going until you've got the frame full, and I'll come back on this once I've got that ready. So that's all the cells with their links separated and folded back in on themselves so they fit through the holders. It's looking at that way. The top of the cell is positive, negative, positive, negative. And I say that first row is all negative ending first. Second row is all positive ending first. Third row negative ending first. Fourth row positive ending first. So the electrical connection will be, this is the negative of the whole pack. Links there to series that section. From positive of that cell to negative of that one. Then again positive to negative, and finally output here, which gives 4 cells in series, 5 connections. I've got a bit of a scrap computer cable there, power supply. I'm going to use that for the wire because it reads my heavy stuff. It's low voltage, and that's fine. It's got plenty of colours, so I can keep everything separate. I've got one last strip of 4 holders to go on there. Just press them into place. I need a bit more of a push down, but that'll do. Then I can start wiring them. Now, with the colours I've got here, I'm going to use black for negative, for the very first negative 0 volts point. Red for the 4.2, orange for 8.4, yellow for 12.6, and white for the 16.8 volt one. And the ends of the chain are the high current ones. The intermediates are only low current as far as the connections to the protection board. I still need to handle full current in the series links. So I'm going to start on that one. That's my 0 volt one. So I'm going to have to probably use the stripping tool for this rather than trying to strip them at that length, because it's quite heavy stuff. It's very hard insulation. It's old cable. It's probably been cooked in a computer case for a few years. Well, the power supply failed. Okay, so I've got lots of bits of wire cut and stripped appropriately, so they will link between cells. There's 8 pieces each for the intermediate links, like there, because it needs 3 on each row that way to link them there, and then a couple at least that way to cross-link to connect the whole set in series, and then just 3 for each end for the single row connections. So these are going to get very hot when I start soldering the bits of wire because they're so short, so I'll probably use tweezers to hold them. But the first thing to do is tin all the ends. So as long as I'm soldering on top of the folded tags rather than directly to the cells, they should tin very easily. You can see it is flowing nice like that. I need to do that to both sides, and then I can start tinning the wires and flowing them into place. And again, I'm not going to show every single link because that's going to take quite a while, and it's all very repetitive once you get started. So I'll just put the first couple of bits on, and then see how it goes from there. I also swapped stripping tools, because the first one was one used for ferrules, and it's a cut and strip tool. You can't just take the insulation off the end of the wire only, because it grips it and cuts it as you do it. And it's a bit long, so I swapped that off the first few. Yeah, that wire is melting. I might just do one end of each and then go and cool again. Oh, sorry. I'm actually off the end of the edge of the mat there, am I? And out of view. So let me do some of the flowed nicely. And it's a little bit long for that one. Ouch. Yes, it's still hot. Just zigzag out a bit so it fits down there. And to get in place. And I've also got to put the next one on top of that. So I've just about finished doing all the cross links. That side's done. I've just got one row to go on there, and then it's time for the connections to the protection board. Now, I've found an easier way of doing these than trying to individually set the ends every time with the tweezers. That is, bend them into a zigzag shape that fits across about the right place. Then you just tack one end of each as you go. If the other one happens to fit down as well, that's fine. It's a lot quicker than messing about trying to set every individually. And then with the tweezers, go along them again. A bit of extra solder, and very carefully keeping the tips angled up so you don't touch the next cell, because that would be somewhat catastrophic. Just reflow it whilst you're holding the metal down until it cools again. Which you can see gives a much better looking joint, as the wire's not trying to lift through the solder blob. Okay, so that's now a 4 parallel and 4 series pack. Negative from there, link through there, link through there, link through there, and finally to positive there. So that should be somewhere between 14 to 16 volts if it's working right. Let me make sure the meter's visible. 14 volts. Yep, that's about right. So that's now ready for the protection board to go on. Now I've got to figure out the best way to put that, because there's different connections at different opposite ends. None of them match up perfectly, so looking at that, it's got the 0 volts and the... Okay, so this is the tape I'm using, and I'm going to put just 2 strips just in from the terminals and leave it mostly air, so it's got cooling around the board. I don't know if it get warm or not, but there's no point clogging it up and insulating the back of it if it doesn't need to be. So now, because that's offsetting a bit and I want a bit of clearance, I'm just going to fold this in half. About that. That gives me a double thickness piece. I've got another one the same. I use this quite a lot. It's my favourite double-sided tape at the moment. It has been for quite a while. I got some to fix the trim on a friend's car. Discovered how good it was. I've used it ever since. Now, before I take the backing off, let's just see how high that supports it. Oh yeah, that's well clear. It's not. What I was bothered about, I don't want it touching the. You can see that. I don't want it touching the plastic ends on the battery brackets. Just make sure those are well set in, and this should just keep it inside. A bit of clearance. Oh, one thing I can't remember I mentioned, before I started paralleling these, I did check the voltage on every cell, and they're almost exactly equal. They're all within a range of about 50 millivolts. And I did a test paralleling the highest one, that's near enough the highest and near enough the lowest voltage with the ammeter in series, and the current between them as they equalised was something like 60 milliamps. It's trivial. There's not enough voltage difference to cause any high currents when I was putting the parallel links on. That is important. That you need to check that the cells are all roughly equal charge, or quite closely equal, so then it doesn't produce any high current surges as you wire the links. That could be, you know, if one was fully charged, one was flat, you could get tens of amps. As it does get a lot stronger over time, but it hasn't done so yet. I can just put new strips on the new board and that'll be fine. Well, more haste, less speed. Should have gone back in its box, not just back on the bench. So, 4.2, yeah, that's that way around. So, a couple of strips on the back, the tape, and stick it down again. Spare bit can go back there. So about there. Put it down the middle again. Always on video. If I was just building it, I wouldn't have got all the extra bits out to demonstrate. Oh well. They need trimming. That's way too long. Make sure it's pressed down well. Right, so 0 volts is in that corner, yeah. Mandatory headbutt the camera. And try again. These wires are already tinned, so not volts. Wonder how many have you spotted the wrong board before I did, as soon as I put it in place. Oh well. Red 4.2. Orange 8.4. Ow, that's a lot. It's funny that. Didn't realise it'd be hot just after soldering, if you're paying attention. And of course, everything goes wrong. Right, might as well tin it properly first. And try and find the hole afterwards. Right, got it. 12.6 this time, hopefully. 8.4. 12.6. Oh, 12.6 is at the wrong end. So, that's going to go back around that way. And then 16.8 is white. Now, actually, I really ought to. I don't know, this is heavy enough. It's only going to be 8 amps maximum. This wire's rated at more than 8 amps. And the chance of it being run for that for more than seconds are very slim. This is quite a heavy wire because it's low voltage wire. It's fairly heavy copper and thin insulation. I'm used to using tri-rated, which is much heavier insulation because it's rated to 1000 volt DC. Whereas this stuff is not high voltage rated. It's more like automotive, which has a lot of copper for low voltage high current and not much insulation because it just doesn't need it. Right, okay, now I can start connecting those. So that one goes to there. That one can go also to that side there. Strip those and put them in place first, I think. Can't do it. Last couple of connections and then it's about done. Just needs an output connector on it. And with this particular type of board, it's the same 2 wires for charge or load. There are some that have got a separate charge and output terminals, different terminal setup. But you treat this whole unit as just a battery with internal protection, a 2-terminal battery. Use an appropriate charger and fuse the load and whatever. And do the same. Same as I was doing with the paralleling wires, just make sure they're fully down against the terminals without shorting anything. Right, red there. Let's go into that one. Yellow's going to go to there. See, these things are complaining there's too much copper and not enough insulation to grip. So if you don't grip squeeze, it just pulls the whole lot straight through the gripping jaws. And so it's a heavy core. Now, when I finish wiring this, I don't expect there to be any voltage coming out of that protection board. That's quite normal, because the default state is shut down. They're activated when you first try and charge the battery, and the idea is it isolates any possible load whilst the things are in transit after manufacturing, or the battery packs or whatever contains the batteries and the protection boards, or protection ICs specifically, if it's got protection ICs. So the batteries don't go flat and get damaged, because over discharge does damage them. Right, that is the last connection now. That is the final positive, and that is a complete pack, which is, depending how you rate it, because at one time they were classed as 3.6 or 3.7 volt a cell, but then basically for advertising purposes everyone started classing them at 4 volt a cell. The same batteries, exactly the same characteristics and voltage range. It's just that someone decided that saying like power tool batteries were 20 volt rather than 18 volt made them look good. There's no difference. They just changed the labelling on the basis that they're just over 20 volt when fully charged on a 5 cell pack or whatever it is. Ooh, that's game one. Got it. Right, that's it. One nominally 16 volt under that. These are supposed to be 2.5 amp hour according to the data sheet I found. So it's 16 volt 10 amp hour battery. And out of curiosity, I'll just check the voltage on the terminals, because these haven't actually got. Have these got any? Oh yeah, the control ICs are there. Those are also about 6-pin packages down there. So I'm guessing some of those are voltage controllers. Now, whether it actually does shut up the output or not, I don't know. But soon find out. So from there to there, we have 14 volts. No, this one doesn't shut the output off. Sometimes do, sometimes don't. But no, there's no overall shut off when it's in range. It's only got the undervoltage and overvoltage cut off. But that's the principle anyway. Well, that's holders have moved a bit. So I hope that's of interest. And as I say, there'll be a separate short video about power tool batteries as well. Anyway, thanks for watching, and please subscribe if you like the content.